Okay, so let's go ahead and get started, guys. So I'm super excited to teach this course because it's Linux. It is one of the very first things you may ever do in IT, and it is everywhere. From your enterprise grade systems all the way down to little embedded operating systems like Raspberry Pis that run just a single thing, kind of like a purpose-built machine. Linux is everywhere. So they always say like Linux gets us to space. Linux gets us here. And it's true. Learning Linux is very foundational just to IT system administration, period. Now, I come from a network automation engineer background. And when we're using Ansible to automate, guess what that's based off of? Well, Linux. We do it from Linux. We manage servers using scripting Ansible, Linux servers. A lot of networking equipment is based off Linux. And I could go on and on and on and on about the different systems and architecture that uses Linux. But what is it? Well, at its base, it's just an operating system, right? It is just an operating system with many different distributions. Now, when we say it's just an operating system, we're really talking about the Linux kernel. That base Linux kernel is everything. And then we have so many other distributions built off that shared kernel. But the history of Linux, where does it come from? Now, this is kind of getting into, this isn't a computer science 101 class in college, but it's based off Unix, or relatively similar to Unix, okay? Now, Linux was obviously, introduced to us, and it was always open source, okay? Linux operating systems, as its genesis, was open source. Now, what do we mean by that? So we have an acronym here that I want to go over called FOSS, Free and Open Source Software. Now, what we're talking about is when I have that Linux kernel, it is free for me. I don't need special licensing. I don't need anything special to build off that initial Linux kernel. So that open source license allows us to do duplication. It allows us to modify. It allows us to have re-release of modified versions and to share. Now, that's just going over the Linux kernel. Other examples of open source licensing is the GPL or GNU General Public License, the Apache license, the Mozilla Public License, so even the Mozilla Foundation. And that's really the character of Linux, that it's open source. So history and philosophy of Unix and Linux. So Unix is an old but commonly used OS. And then Linux is licensed as the open source by the GPL. Linux has multiple different versions, and these are purpose-specific, and they are called distributions or distros. I have other operating systems up here, Unix. So like BSD, Mac OS is based off Unix. Then Linux is based off Unix, right? But Linux here is all open source. Now, of course, there's a caveat here for this symbol. That's Red Hat Linux, which is an enterprise-grade Linux operating system and distribution that is licensed. That we can build off it. We can build different versions of RHEL, like CentOS, Fedora, but actual Red Hat Linux is something that's enterprise-grade and includes support. So I'm talking all this awesome stuff about Linux, how it's open source, but what's the downside? So because it's an open source system, it is community funded. Now, obviously, there may be some money elsewhere going into like the Ubuntu ecosystem, but it's like crowdsourced. It's community patched. Now, obviously, Ubuntu as a company now, it's gotten to a point where they maybe have like developers on standby to do patches, but it is community run, okay? So there are Linux distributions out there that, there may be a public GitHub repo that says, hey, here's the update. So sometimes for your enterprise, if you don't have seasoned senior Linux administrators or engineers on there, sometimes Linux is not going to be what you want to use for enterprise-grade things. However, it does work really well for like different types of embedded operating systems, machines. So when we use it, it's kind of up to you. Does it fit your organization? Do you want an open source that if there's a CVE that comes out, is there a vendor that's going to fix that vulnerability? Well, maybe if you do want that and you want to use Linux, then you go with RHEL. Maybe you're just testing things at the house. Maybe you want to build a web server and you don't want to pay for like Windows Server and you don't want to build off, Windows Server anyways. So you use a Linux-based server, like a Debian-based one that's open source, free for you to download, okay? All this to say that Linux has a broad ecosystem that is community funded, but there are some caveats with this enterprise grade here, RHEL. Now, as far as all these distros relate to the Linux Plus exam, Linux Plus exam, I kind of look at it as it's teaching us the Linux kernel and then the operating systems built off of that and how to interact with that. It is kind of a test that's built towards a Linux system administrator. So editing files, doing permissions, creating user accounts, managing a Linux ecosystem. That's kind of what it's built for. So during this course, I am going to be doing our labs mainly with Debian base because that's going to be the most widely used as far as like if you want to get into Linux, you probably download Ubuntu. But I will have Fedora as well, and that's based off Red Hat Linux, which is not completely open source. Remember, you do have to pay for Red Hat Linux enterprise grade operating systems, and with that you get the support of Red Hat Linux, okay? Now, if we just quickly go online here, and just let's just look at some of these different distributions, right? So we go to Ubuntu. What's the parent company? It's like Canonical, something like that. You can see that this is just all the different open distros that Canonical has, and Ubuntu being the biggest one for like someone just starting out. You can see their products here. You can download Ubuntu Desktop, Server, Ubuntu Pro, and look at that has subscription base. So that's why I said they kind of expanded, right? But it is still community supported. There's documentation on here. If we look at RHEL, Red Hat Enterprise Linux Operating System, you can kind of already see from the website the difference here. This is enterprise grade. Now, I understand that maybe some of you have not worked in IT, haven't been on an enterprise. So when I'm saying that word, you're like, what are you talking about? That's your corporation. So, I've worked in the DoD. I was in special operations. So my enterprise was SOF, our special operations enterprise. And when it comes to the IT infrastructure, we had data centers all over, cloud-based systems. And if we had anything that was enterprise grade, meaning we wanted support on the deployment of a technology, we wanted it to be Linux-based, we probably were going with RHEL, okay? So how to buy? So you buy RHEL. Unlike with Ubuntu and these other open source Linux-based systems, you just go download it, right? Okay, so kind of showing you the difference there. Now, RHEL is a major distribution. Where Ubuntu is a distro, Ubuntu is based off something called Debian, okay? See, it's called the Universal Operating System. Debian is a distro, and then there's multiple, you can almost call them nested distros under Debian base. So like Kali Linux, Ubuntu, those are all Debian-based operating systems. So commands you may do in something like Kali Linux will be the same commands you do in Ubuntu because they're Debian-based. Now with RHEL, this is kind of the universal distro for things like CentOS and Fedora. They're forked off the RHEL distro without the actual paid support. So those are kind of like open source RHEL distributions. But all those different distros are based off one thing, guys, and that is the Linux kernel, okay? They're all based off the same Linux kernel. And when we get into things like containerization, that's going to make a lot of sense. Anyways, before getting ahead of myself. So for this course, I will be switching back and forth between Kali Linux, Ubuntu Linux, which guess what? It's going to look, the commands are going to be almost the exact same. They are the exact same commands. Obviously, we point things differently. Like if I'm downloading something for Kali, I may point to a Kali repository, where if I'm downloading and doing updates for Ubuntu, I'm pointing towards Ubuntu's repository. But the commands are the same. When we get in our Fedora machine, which is based off RHEL, the commands are going to be different. There's going to be different package managers. So with Debian, you're going to see a lot of apt. That's our package manager. And with Fedora, which is based off RHEL, you're going to see Yum or RPM. That's how we download and install, and that's our package manager for RHEL. Okay? But they're all based off the Linux kernel. Okay, let's get back to our slides. And then just to make, if we're looking at a Venn diagram, open source, well, what's the opposite? That's closed source. That's Windows and Mac OS. Because you have to pay for them, and we can't build off them. So even though you pay for Red Hat Linux, remember, we have distros that build off it, like CentOS here. Okay, so just the history. Unix was released. Then in 1991, Linux was released. That was the first Linux kernel. And this just kind of shows you the open source operating system, how it evolved throughout the years. And it's up to 2023. Maybe I should change that because we're in 2025 now. Maybe I should get a different chart. But you can just see this huge tree all going back to Unix and how it was based off Unix. So you can kind of see here, Unix-like systems, Linux was released. And that was the first Linux kernel, 0.1 to .98. And now we're currently in this Linux kernel, 2.0 to 6. Whatever we're on right now. Okay? So this is Unix-like systems. And just in case you guys want to know who invented it, it's Linus Torvald. Always forget, but he created Linux in 1991. He has so many videos too, like on YouTube, that you can still watch. So he's still very much involved in the community. Well, I don't know him personally, but you can still go see his videos. Okay, so traits of the Linux operating system, just so we can kind of go over these slides. Free and open source, no licensing fees. Security, frequently reviewed for vulnerabilities by a large community. Support can be community and vendor support. So remember, big range of Linux distros that we have. So community support, like probably Fedora would be community supported. And then vendor support like RHEL. Performance and stability, known for high performance and stability. And a great example of this, let me just step out real quick and I'll turn my camera on for you guys. So if you ever want to rebuild like a machine, let me stop sharing my screen. If you ever want to like rebuild a machine, I have this old ThinkPad here. You put Linux on it and all of a sudden it's performing like it's brand new. Okay. This is like a 10-year-old machine, old processor, beat up. I think it's solid state drive. Not a lot of RAM, good RAM. It's like DDR2 or 3 maybe. And you're like, oh, this can't run Windows 11 at all. You put Linux on it, it's like a brand new machine. So this is actually the kind of Linux machine we're going to be using for the whole class on this old Lenovo ThinkPad. We'll put it back on a charger here because the battery dies in like literally 5 minutes. It's old. Okay, we're back. Let's share my screen now. So performance stability, known for high performance and stability. That's kind of the point I'm trying to make there, is that you can pretty much give life back to these old machines that maybe they don't work. And then they're great for lab environments too. Like if you have an old shitty laptop somewhere you bought when you were a freshman in college and you're like, whoa, this ain't gonna work. I should have not gone to Walmart and got that HP or Asus laptop because it was cheap. You put Ubuntu on there using like a bootable USB drive, which I'm gonna show you in today's class, you'll get a brand new computer. Software availability, so different software from other OSs, hardware requirements, they consume fewer resources. So if we come back here, I'm trying not to be sporadic. If we come back here, let's go back to Ubuntu. We like the server download, system requirements. You can see you need 1 gig of system memory. So really lightweight. If we compare that to, let's say, Windows Server 2022 system requirements. Now, obviously, they have the core now, like server core. Diving into Microsoft documentation. There's a Linux class, okay? We just want to show you the comparison. How much RAM do you need? So 4 gig is recommended. Yeah, you do 2 gig. You might as well not even have Windows Server. But you can see the difference there, right? How it's way more lightweight. And then also, which we'll learn about, you can, with containers now, I mean, it even becomes more lightweight, these Linux-based operating systems, okay? Hardware flexibility, it runs on a wide variety of hardware. So if you haven't taken A+ yet, you know that operating systems can really go on any hardware. If we tried really hard, took an old MacBook, we could put Linux on that MacBook. There's a lot of enthusiasts on YouTube that show you how to do that. It's flexible, okay? It can run on really any type of compute hardware. And then, of course, distribution creation. Users may create their own distribution to meet needs. Now, that's a little crazy, right? Unless you're a super nerd and you want to build your own Linux distro, that's the best way to learn Linux. Don't even come to Linux Plus. If you just build your own distro that works for you, you put a desktop environment on there and you work through all those packages and putting the drives and the bins and the libs on there, good for you. But again, you can purpose build Linux because all these distros are based off the shared Linux kernel. Okay, thousands of distributions. Most distros are derived from RHEL or Debian Linux, which I kind of already talked about. Just some more releases here. Debian was released in 1993, and then Ubuntu 2004. And again, that's kind of like Ubuntu. Like, really, we like users. You want to get into Linux? It's Ubuntu. And then Red Hat came out in 1994, which always surprises me when I teach this because I feel like they just had a nice steady climb. And now they're very prominent, especially like in the cloud, major data centers now. And then Android's also based off Linux as well. Here's some of the common distros. Fedora, that's RHEL, Ubuntu, Red Hat, Linux Mint. And then Debian, OpenSUSE. And then common server deployment. So obviously, CompTIA, they want you to take Linux Plus, not just to be a little tech enthusiast in your shop like an old school wizard building stuff, maybe hacking. They want you to get this skill to go work on an enterprise, get a job, and, be part of society, be a working member of society. So I put on their common server deployments because that's what I believe CompTIA wants you to think about in perspective of Linux. Like, hey, what does Linux bring to the internet? What does it bring to your corporation, your enterprise? And here's the common server deployments you may be administrating, okay? So web server, name resolution, so DNS server, file and print services. Linux is used for a lot of log aggregation services. Virtualization and container hosts. So with Docker and containers, that's huge for Linux. Now, containerization is the new way forward for our data center builds and our cloud native applications. Our applications that run in the cloud, they get containerized now. That's all based off the Linux kernel. Databases. So all of our databases, whether we're in the cloud or still on-prem, SQL, NoSQL, MongoDB, whatever the case may be, it's going to be based on a Linux operating system. And then, of course, clustering. What we're just saying there is that you may have a bunch of Red Hat RHEL servers. You cluster them. That's kind of just getting into server architecture, more or less. We could do that with Windows, too. So how do we interact with Linux? So throughout this course, I'll be going back and forth between the GUI and the CLI. Now, we call this bash, the bash shell in Linux. So that's when we access through a command line. It's using bash. But as you're going to see, I'm going to be using secure CRT, terminal, and the actual shell in a Linux machine as well. But you also have the graphical user interface, the GUI. So there's a bunch of common GUI builds for Linux. You have KDE, GNOME. With our Debian-based systems, I'm going to be using GNOME GUIs. And this is just how you typically interact with the computer. So when you're starting off learning Linux, my recommendation is don't go get a server OS right away where it's just a CLI. You may get frustrated with yourself, right? Go get like maybe Ubuntu desktop and you can still build and, you still configure server services on there. And that's going to come with the GNOME desktop, okay? So some advantages when using purely CLI versus not purely CLI. So quicker to perform tasks. Most system administration happens from the bash shell, okay? If you're a system administrator managing Linux web server farms, you're using either bash or some sort of configuration management tool like Ansible, Terraform, which is, again, CLI-esque. So CLI advantages, quicker to perform tasks, performance due to consuming fewer resources. Scripting allows complex commands to be combined, automated, and scheduled. So if you're a bash shell scripter, cron jobs, bash scripts can allow you to have kind of like that infrastructure as code feel to run scripts for mundane tasks. Now the disadvantages. When you're just starting out, you're deploying applications, services on Linux. If you just have the CLI, it may have that high learning curve. Command syntax is always hard. Non-intuitive and inconsistent command structures across the distros. What we mean by that is with Debian-based systems, we use APT, the apt package manager, to install, to update, to upgrade. And then with RHEL, we use yum or RPM. So that's what I mean by inconsistent command structure, maybe across the different Linux distributions. Now to show you without just talking about it, so we got a couple things spun up here. So I have my Kali Linux machine and a Fedora machine here. So I have it up here on Secure CRT. Secure CRT is my terminal emulation program that I'm going to be using. I'm SSH into this Kali Linux machine, and I'm SSH into this Fedora box. That Kali Linux machine I just showed you on the camera, I'm just SSH to it from my MacBook where I'm teaching, okay? Now this Fedora machine is actually a virtual machine that I'm running. I'm going to bring it up here. And here's the GUI, right? So I'm SSH to this machine, but there's also a GUI that I can access as well. So if I want to look at all the applications I have installed, get on the internet using Firefox, right? Like our open source internet browser, I can do that from the GUI. So I have Firefox up here on my Fedora box. We'll go to YouTube here. Now, one thing I want to show you guys, so check this out. If I come back here, and let's just do some commands. Don't worry about writing this down. I'm going to show you how we can manage that box from the CLI. So you see this netstack command. See how I have Firefox opened? Let's go kill that process. 6861. Don't worry, we're going to learn about process IDs and all that. I got to put in my administrator password. Oh, sudo kill tac9. Let's kill that process 6861. And if we come back to our box here, let me get into my root. Hold on. There we go. Now if we kill that process, I had to get administrative privileges, okay? 6861. Look at that. So we're managing this box from a bash shell using this terminal emulation program, Secure CRT, and we're SSH'd in, okay? So just kind of showing you the difference there. I killed Firefox from the CLI. I could have easily have, come here to activities, open it up, and hit X right here. That's kind of the difference, right? So this is CLI versus GUI. And throughout this course, yes, we're going to be going back and forth a lot, okay? So common CLIs, we have Bash, that's the default Linux shell. We have these other shells here. The feel, you may have different colors, maybe different features with different shells. What you saw me on is Secure CRT as a terminal emulation program, but I was still in the Bash shell because that shell interacts with the Linux kernel. We'll get into this, okay? Just introduction. The other common GUIs, so we have GNOME, which is what we're going to be used to on Ubuntu. And then we have these other GUIs here that we're not going to go into detail with, okay? All right. So that's going to be it for our Linux introduction. So I yapped for about 25 minutes. Let's go ahead and take another 10-minute break. Let's come back at 6:05 East Coast time. And then we're going to get started on our first lesson going over the Linux file hierarchy system. Okay, everybody, let's go ahead and get started. So before we actually jump into the lessons, I want to get everyone at least showing you how to get a Linux machine up and running using virtualization. So let's go over what we got here. I'm going to unexpand this. Okay. So I'm on a Windows machine here. I know it looks a little funky. Like I'm using TeamViewer. I teach on a MacBook, and MacBook virtualization on the new architecture, like this ARM architecture, is kind of pain in the ass. So I'm on a Windows 11 machine here, and I'm using VMware Workstation Player. Now this is free. On our Google Drive, you can download it directly. If you try to use Broadcom's website, ever since they purchased VMware Player, good luck, right? It is a pain in the ass. This is just the virtualization application I use. We call this a hypervisor, a type 2 hypervisor, because it's running on your desktop operating system. So I'm in a Windows machine here. I have VMware Workstation Player up, and I'm going to show you how to download Ubuntu Desktop, download Fedora. It's all online. It's pretty simple. And then we're going to go through making those virtual machines. Yes, this takes a little bit of time, but I want to get this done out of the way first so that you can also be in a bash shell with me as I start doing commands, okay? So I get this out of the way. Now remember, if you want access, there's our VMware Workstation Player right there, okay? You can get it from our Google Drive. Now let's head back. I'm on a Windows 11 machine. So before, what I did is I just came here to ubuntu.com and I downloaded this Ubuntu Desktop. Honestly, it doesn't really matter. I just got the newest version. LTS stands for long-term support. So that means like, hey, this is the currently supported one, that you'll get like vendor support. You know, remember open source, so vendor support for it. Pretty much they're going to keep updating this one. So that's the one I downloaded. Look at the file size here. It was 5.8 gigs. And then Fedora, just typed in the same thing, said download Fedora. And here you have to choose the architecture you have. So I downloaded this one for Intel and AMD processors on an 64 system. So that's the architecture I'm using for my Windows 11 machine. But if you're using ARM, you have to download this one, okay? That's what I use for my MacBook using VMware Fusion. A little different. If you have Hyper-V, if you're using VirtualBox, that is totally fine. As long as the ISO will fit the operating system's architecture, meaning you're using VirtualBox, Hyper-V, and you have an Intel and AMD processor with the 86 architecture, you'll be fine, okay? I'm just using VMware Workstation Player. It's what I'm used to. So go ahead and download those ISO files. And then to actually get this VM up and running, of course it wants to freeze on me. Why was it get going? Okay, there we go. What I'm going to do here is come here to Player, File, and New Virtual Machine. Now again, depending on what you're using, this is going to have a similar kind of style. You just need to create a new virtual machine. So we're going to do that. And then we have to pick our installer disk. So an ISO file, that's like the operating system. That is .iso is the installer disk, okay? The image file. So I'm going to install this Ubuntu operating system, then I'll do the Fedora one. So I came here, and I went to Browse. I went to my Downloads folder, and there we go. I'm going to hit Next. Now, we'll give it a name. We'll just say Linux Plus class. A username for the actual system. So we'll just put my first name, Johnny, and you're going to put a password. Now, this is local. I mean, don't worry too much about password security. It's just a little local. Then the actual virtual machine name. So what we just set there is a username and password, okay? And this is virtual machine name will just come up here like in your actual hypervisor, what it's going to be called. So we'll call this Linux Plus Ubuntu machine. We'll hit Next. Now we have to give it disk size. Now obviously this is going to depend. Like if you have a 1 terabyte drive, you want to give it 100 gigs, whatever. If we looked at the system requirements again, we come back here. System requirements, 5 gigs of free hard drive space. That's the minimum we need. just going by the documentation here, I'll go ahead and give this like 40 gigs, okay? Just to play it on the safe side. Those 20 gigs would be fine too. I just don't like using defaults, right? So we have an option here. So split virtual disk into multiple files or store virtual disk in a single file. I mean, we're just testing things out here. You can read what the difference is there. That won't be on our Linux Plus exam. Okay, let's hit finish. So now this will go through and it'll install Ubuntu. So this is one way to install it as a virtual machine. Now, if you do you can put that ISO on like a bootable USB, and you can go take that old computer or laptop you have and install it. You're going to get a few more options of what you're going to see here. Before class started, I ran through and did this, and it just brought me like right to like the desktop, right? But there may be other options when you first install Ubuntu on like a actual bare metal device where you set the time and other things like that. Okay. So I'm not going to watch this, install, because it's going to take up too much time. But that's the process of installing Ubuntu on a virtual machine. Now, we'll come back and I'll show you the Fedora one once this is finished. In the meantime, let's go ahead and go back to our slides. So I'm going to bring up now going over the file system hierarchy standard. So FHS. So what are we talking about here? So back to kind of the fundamentals of Linux. So Linux as an operating system is just files and directories. When I say directories, that's the actual, that's the correct way. Folders is interchangeable, directories, folders. But all Linux is a bunch of directories with files that make that Linux machine work, okay? So the file system hierarchy standard is from the Linux kernel how all Linux distributions are going to, not how they're filtered, but it's just going to be their standard, right, of how they organize the operating system. So the FHS provides standardization for file locations. And again, the standardization allows application installers to know where to put configuration files, log files, and documentation. So what we're saying in here is that no matter what distro you're on, we're going to have a standard. And from the top level directory here, from the root, we're going to see all of our top level directories. And we're going to go over all the files in them and what these directories do. Because every directory is going to have a specific purpose within the Linux operating system. Now, if you're using Debian or RHEL, this is going to be the exact same. With some, of course, caveats. There will be some caveats, like the snap directory is something that may be in addition to like Ubuntu that won't be on RHEL. And we'll cover that. So standardization allows users and administrators to anticipate where certain file types may be found. So we have a nice image here with our root directory and all the other directories in here and what they do. So I'm going to go through this one by one, okay? So bin. These are going to contain essential binaries required for the system to boot and function. So this is going to be where all your binaries are, okay? So when I'm doing basic commands like ls, the rm command to remove, the mv command to move files, those are all located in this bin directory here. The boot directory. So this is going to contain all the files needed for booting the system, which we're going to get into. So our bootloader configuration files that are part of Grub are going to be in here. The init.rd, the initial RAM disk for bootstrapping, is going to be in here. VM Linux, so VM Linux with a Z at the end, the Linux kernel will be located in this, okay? In our boot directory. Our dev, so this is going to be where all of our hardware devices are. So where we would partition our hard disk will be here in the dev directory. And then etc. So this is going to be for the host-specific system configurations. Sorry, I have my notes over here. Okay, so in the etc folder, there's going to be system-wide configuration files for services and applications. So this is critical for our system functionality. So configuration files, there's going to be like, if we have hosting a web server, configuration files in here that web server needs. Our user account information is in this etc folder. Our passwords for those users are in this etc folder. We have things like our network interfaces. So that's our network configurations are going to be in this etc folder. So if I want to set a static IP from the CLI, if I want to set my host name configurations, I can do that in the host file in the etc folder. Then the home directory, that's where all of our users live. So every regular user is going to have a home directory, and that's where all their personal files, their documents, their desktop, their download folders are. User-specific configuration files. So if you have a specific configuration file for that user, maybe in the .bashrc or the .vimrc, as an admin, maybe you have certain settings for Vim, a text editor that you want. That's going to be in your home directory. The /lib, so that's going to be your shared libraries. So it's also could be written as lib64 too. So it could be /lib64. This is going to store shared libraries required for the system boot and operation. So like the standard C library, all your kernel modules will be here. So we talk about the binaries and libraries, like for containerization. We're talking about these directories here. Media. So this is going to be where all your media gets mounted. So if I plug in a USB, that USB is going to be in this directory under the media directory. So automatically mounted USB drives, CDs, DVDs appear here. Then we have the mount for our mounted file system. So it's going to be a temporary mount directory. So for example, if we mount our SDA drive under the dev directory, we can temporarily mount it to here and then plug in a USB. So it's used by system administrators to manually mount file systems. /OPT. So this is optional software. So this is going to contain all of our third-party applications and software packages. So if I go install Chromium, which is like the base for Google Chrome, but Chromium, something we can use in Linux, but like the open source Chrome, it's going to be a lot of its configuration files, and that third-party application will live here in the /OPT. Temp, or TMP. This is where our temporary files are. So these are temporary files that may get deleted on reboot. So you kind of think of this as like almost cache or like volatile things, okay, are going to be in the temp directory. And then we have the user or USR. That's a user program. So it's going to store user utilities, libraries, documentation, and applications. So for example, non-essential user binaries like our Nano text editor, Vim. Non-essential system binaries like if we have a web server, like Apache 2 and Nginx if we install that. Now I'm saying non-essential. What we mean by that is like the binaries I need to run a web server on a Linux operating system, they're not essential for the Linux actual machine to run. They're essential for your web services, but those kind of binaries are going to be stored here in the user utilities and applications. Okay? So that should cover it. We have some other ones like var, so /var, that'll be variable data. So I'll draw it on here. So /var, that'll be for variable data. So our logs, like that's a big one. Like in cybersecurity, if you're doing log dives, that's going to be in the var log. That's another big one that I don't have in this image here. I /snap, like I've told you before. That'll be for like Ubuntu images. We have something called the /srv. So service data. This would be where, like, if we're running a web server, this could be where our web files could be living in. Could be, okay? So this is data used by system services, like web services, or you could even have, like, FTP services running in here, okay? So without getting too boring, those are all the directories, okay? Now we have some key directories we're going to talk about here. Now before we get into that, let's go ahead and check in on our VM. So look at here, guys. On my Windows machine, we have our Ubuntu machine running. And this looks like, this is running the GNOME desktop. And again, it just looks basic, right? It just looks like a regular operating system. Now this is our GUI we're interacting with. If we want to look at all of our apps here, we can look at this. We can open up a bash terminal here. Okay, this is what Ubuntu's bash shell will look like. A lot of like YouTubers or people online giving free training that use Ubuntu for Linux, this is what you'll see, like this purple background. So that's how easy it is to get Ubuntu up and running, okay? I'm going to power off this virtual machine. Okay, I just need to be patient. That's one thing too in IT, guys, like something that I've had to work on is my patience. Like, I just want things quick. You know, it's the Gen Z in me, I guess. But there's our virtual machine. Now, taking a little break from FHS, if we want to install Fedora, it's going to be the exact same process. Give it a virtual machine name. So we'll say rel-based system, Fedora. We'll give it 40 gigs as well. Let's go ahead and finish. So you notice that from the hypervisor prompt, it didn't ask us to put a username and password. And that's because when we're installing Fedora, see, it gives us a little bit more options. See, this is the grub. This is our bootloader here. So we're going to start Fedora. It gave us options at our bootloader there. And we're going to get into the boot process here shortly. And that'll make more sense what I am talking about. Okay. Now while this loads up, guys, let's go back to our slides. All right, so some key directories here. So kind of just to reiterate, and when we say key directories, this is going to be as an administrator. A lot of where you're troubleshooting, a lot of where you're finding things is going to come into play. So Etsy, this stores configuration files. The home directory, that's your user. The root, so that's the root of our file system hierarchy, right? The root directory. And var/log, this is all of our service logs and system logs are. So if you're having trouble starting a service, like let's say you created a Damien startup service and using the systemd, you're trying to enable it and start it, and you're like, why isn't this giving you an error? Its log will be stored there, okay? I know I'm using a lot of acronyms and talking you may not understand. All right, let's go ahead and get into a system now. And let's go ahead and let's clear this. We'll clear this. Let's go ahead and navigate through our file system hierarchy, okay? So right here, if I type in pwd, this is going to show me my present working directory. Actually, what I'm going to do, nice thing about Secure CRT is I can send these commands to all sessions. So I do pwd, that's going to show me my present working directory. You can see I'm in my home folder on both machines under this user. So I'm in my users directory. If I type in ls, this is going to list. This is going to list all the directories underneath it. If I type in cd and I go to desktop, it's going to move me into that desktop. You see here, even on our Debian-based Kali Linux machine, and our RHEL-based Fedora machine, it's kind of prompting you here to show you your working directory. If I type in pwd here again, it's going to show me where I'm at, okay? I know it's like maybe like ADD, you're like, dude, you're doing it on two different machines. Which one should I look at? Just choose one, okay? I just like to show the differences between RHEL and Ubuntu like this. Now, if I want to go to the root directory, I type in cd here and this slash. That'll bring me to the root. I type in present working directory. It'll show you like, okay, you're at the root of this FHS now. If I type in ls, it'll list all the directories. So let's take a look here. What maybe some differences. So this is my RHEL-based machine. This is my Debian-based machine. Now, this is a standard that all Linux operating systems should abide by. But if we check it out here, you can see that there's some things here that aren't the same. So in our RHEL-based machine, we have this AFS directory that we don't have here. So there will be some differences. But for the most part, you can see they're doing the same thing. Now, I'm just going to focus on my Kali machine here. If we come in here to, let's say, the Etsy folder or directory, type in ls, you can see all the files and directories in here. If I type in ls-la, what's nice about this view is it'll show you the permissions, and it'll show you with this lowercase d here if it's a directory or if it's a file. Now with Kali Linux, you can see it's kind of color coordinating things for us. You can see here there's a symbolic link, which we're going to touch on today as well. But quickly, you can just use this ls-la command to run through and see what's in your directory. Type in clear here. Now, if we go into our home folder, let's go to our user. Let's go to desktop. If we make some folders here like test01 and nest it with test02, okay. We'll just nest it. We'll go test01. We'll make another directory here, test02. And we can use this .dot command to back out of it. I want to show you guys this command called tree here. With this tree command, this will show you kind of the structure of a folder. So it'll show you, hey, this is the main folder that you want to look at, and then this is the subfolder in there, or the sub files. So if I go into test01, test02, I can create some files here. Touch file 1, touch file 2, touch file 3, back out again, back out again. If I type in tree, hit the tab command to complete that, test01, you can see how it's showing us that, okay? So that's a quick way we can look at like our file hierarchy. Now, of course, when we talk about FHS, it kind of just to touch on this actual lesson here, this is what it looks like at the root of the system. If you ever want to look at what directory you're currently in, it's the pwd command. That'll show you your present working directory, okay? Let's head back to the slides here. So we have other commands here if we want to look at files or directories. So the stat command, this is going to display a file's metadata, such as the file size, the access information, and the storage of it. And then this command file will show you what type of data is in there. So if it's ASCII text, if it's like a hexadecimal, maybe that's like somewhere in a log, a hex dump. Then the different paths. We got to understand the different paths here. So the absolute path. This is going to depict the file system location beginning from the file system root. So if we look at the absolute path, it's always starting at the root, and then it's going to work our way down, okay? So if we type in change directory with a /, we can start at the root here. The relative path. So if I'm in my SSH directory, and I just want to get into this directory here, I don't have to type in the full path here. I can just type in the relative path. Because the system understands, okay, I'm within the SSH directory. So if I type in CD and then here, I understand that I'm within that working directory. I can go to it. But if I try to run that command from root, just CD /config.d, it wouldn't work, okay? So that's the difference between the absolute path and the relative path. So let's check that out here. So we type in pwd, I'm at the root, we'll go ls. So let's say I want to go to home, Kali, my user, desktop, and test01. So now I'm in the test01 directory. I type in ls here. Maybe I type in ls-la because I want to see, okay, what I have. There's my directory here, test02. If I want to get into test02, I don't have to type in the full absolute path. I can just type in cd test02 here, and it lets me get there. But if I try to do this, change directory test02, where am I at? I'm at the root. It's going to give me an error. Say, hey, that's not going to work. So if I want to get into this directory, and I'm currently staged in the root, I'd have to put in the absolute path. So home, Kali desktop test02 slash test, or test01 slash test02. And now I'm there, okay? So that's the difference between absolute path and relative path. And really the point I'm trying to get across is using the PWD, the ls commands, you can understand where you're at in your bash shell, okay? Now, of course, it'll show you this too with this, what's it called? The tilde? That's going to bug me. I looked it up in the break. Representing, right, like, okay, you're at your home directory, okay? All right, let's clear this off here. Let's check back in on our Fedora machine. We may have to wait till our second break here. It's taking a little bit. Here we go. So here at our Fedora machine, we can see how easy that was to install as well. And now we're at our applications. So deploying a virtual machine is it's pretty easy. Now, if you guys, again, when you install a machine from like a USB, a bootable USB, into an actual computer, so you're not doing like virtualization, it's going to ask you for a lot more options, like what's your time zone in, what's the user password you want to put, what's the root password you want to put. So sometimes you get this like false sense of like, oh, that's so easy, but when you're booting actual server, you have to do a little bit more options, okay? Selecting the RAID, other things like that, which we'll get into. All right, awesome. So I've yapped. Oh, here we go. Let's do this. So this is the options I was telling you about, where you got to select your language here for Fedora Workstation. Let's see the time and date. We'll do New York. We can configure the network time protocol. We can do that. We can use this public NTP pool. We can add a different one if we wanted to. Hit done here. Installation destination. We'll say 40 gig. NVMe 0N1. So this is going to be different from our physical computer I have of Kali Linux. It's going to be SDA. That's going to be our dev where it's going to mount. But instead, it's called NVMe here on virtualization. We can add a disk if we want. But this is just saying we're going to take up 40 gigs of my actual host device here, my Windows machine. Hit done. What happened here? Hit done here. Okay. Alrighty. So let's go ahead and take a break, guys. When we come back, we'll finish up this Fedora installation. Let's see, it's 6:33 here. So I'll put 10 minutes on the timer. We'll come back at like 6:45, and then we'll finish this installation, and then we'll jump into our next lesson on our slides. Oh, I didn't see a chat here. Okay, guys, let's go ahead and jump back into it. Just to recap what we just went over. So we just went over the file hierarchy, the file system hierarchy standard. Essentially, that's just how a Linux operating system is laid out from the top level directories, from the root directory and on. Now, if some of you are brand new to Linux, you may just be like, holy shit, dude. So just to kind of compare this, where is my team viewer at? 1 second. If you look at like a Windows operating system, let me bring this up here. One second. There it is. So if we bring this Windows operating system up here, what we're talking about, the file system hierarchy standard, it's like the C drive. Imagine the C drive here is the root. It's the root folder directory, and then all these folders underneath. Then we have users, and the username, that's like the home file, okay? Very similar. Or how the system32, so if you go to like Windows, this is where all of its directories are needed for Windows operating system to work. That's the same thing in Linux, okay? The FHS, the file system hierarchy standard. That's an easy way for me to relate it to someone that may be used to Windows. Okay, now let's finish our installation of Fedora here. So, just going to hit begin. You can start we look at this installation progress. I'm not going to leave it on here, but it's going to start building our operating system, its boot process, all the bins and lids, all the dependencies, all the directories that it's going to need from that ISO file. It's going to partition our computer's hard drive as well and put that operating system on that actual hard drive, okay? We'll come back here because our next lesson is, guess what? The Linux boot process. So now we're going to go over the actual Linux boot process here. So, in the exam objectives, they want us to go over quickly the boot process and the other boot sources. So what I'm going to talk about here is just a standard Linux operating system and how it boots. Meaning you grabbed a server, you installed the Ubuntu server on it as an operating system. How does that boot? Now, of course, in an enterprise, there's other boot sources. So what we mean by that is we take an image, like you just saw me do on VMware Workstation Player, and it's a .iso file. You install that operating system. So you saw me do that with virtualization. But there's other sources to actually boot our Linux operating system. So we could put that on a USB drive and have a live OS, or we could have a bootable USB that'll put an image on there, put an image on our desktop or our laptop. Our operating system can already be installed on our solid-state drive or our NVMe drive, and we're going to have a boot process there. We can have a pre-execution environment, what we call PXE, where we boot an operating system over the LAN, which is a whole process that I could take an hour describing how to build. It has to do with DHCP, options on the DHCP server. Then we reach out via TFTP to a deployment server that feeds an operating system over the LAN, so via IPv4. But those are all of our boot sources. But once we actually get Linux installed and we restart our machine, what's the process? Okay, so we're gonna go over the step-by-step basic Linux boot process. So I am going to actually bring up a whiteboard here, and I'm going to draw this out with you guys. Okay, so step 1 of the Linux boot process. So this is going to be the Linux boot process. Now this is just going to be an overall kind of a standard process. If some of you guys are like, oh, actually like MBR was used in this version of Linux, I understand. For the Linux Plus certification, this is what they want us to talk about, okay? So we're going to go over the standard Linux process. So step 1 is going to be the BIOS or UEFI initialization. So BIOS is kind of old school. You know, BIOS isn't really used as much anymore. For our modern systems, we use UEFI. That's our secure way of booting, the Unified Extensible Firmware Interface. Whew. They do the same thing though. BIOS, UEFI do the same thing. UEFI allows us to do secure boot. We have those TPM chips on our motherboard that are verifying that we're using original equipment manufacturers and we haven't been tampered with. Anyways, they do the same thing though. So when the system's powered on, we do our BIOS check or our UEFI initialization. And that's where we check to make sure that all of our hardware components work. So we're going to initialize our components like the CPU, memory, disk controllers, and all of our peripherals, okay? Let's see. Is this supposed to go here? Okay. What it's also going to do is the firmware now in our UEFI initialization is going to search for a bootable device. Now again, this could just be the hard drive or the solid state drive that's already internal on that system. If it doesn't have an operating system there, it's going to go through a selection process saying, oh, maybe it wants me to boot from a USB. It's going to search its USB. That's a peripheral too, what it's searching for, right? That USB 3.0 that lives on the motherboard. Maybe it doesn't find it via USB. So it's going to go look on the LAN. So it's going to try to do a pre-execution, a PXE boot, where it's going to say, well, maybe I'm plugged in somewhere. I can do a DHCP request. So the firmware then searches for a bootable device. And then from there, once it finds one, however it does that, so whether it be SSD drive, the NVMe drive, it's going to load the bootloader from the disk boot sector. So it's going to find that operating system, and then it's going to load up the bootloader, okay? Now that bootloader is going to take us into our next step, where we're going to do bootloader execution. So now we're going to do bootloader execution. Now this is going to be in modern systems called Grub, okay? Or Grub 2. So this is our bootloader. You actually saw it when we installed Fedora. You saw the options. That's going to be our menu, okay? And that bootloader is going to present a menu to us that's going to say, hey, how do you want to boot? And once we select that, it's going to boot into our Linux kernel, okay? So the bootloader, typically Grub 2, is going to be responsible for presenting a menu to select the kernel and then loading that selected Linux kernel. And then it's going to go into our next step, which is kernel initialization. Why does it... Hold on real quick. I have notes over here that I just prepped. It's like not copy and pasting as I want to. So the bootloader is going to come up and that's going to present a menu to select a kernel, okay? And then once we select the Linux kernel, so this is going to look like to you, it's just going to say, oh, boot Ubuntu or boot Fedora. But then from there, we do something called kernel initialization. So the kernel is going to be loaded into memory from the bootloader, and then the kernel is going to initialize our system hardware. So this is different than our BIOS check, where we're just checking to make sure the firmware is good and it can load. The kernel is actually going to initialize the system hardware. So that's going to be our CPU, our memory, our input and output devices. Now, once it does this, the kernel does not yet have full access to the full file system. Now, what I mean by that is when we initialize our kernel, it's not going to initially have access to like our root partition and to our Linux distro, okay? We have another step here called the init-rd, the initial RAM disk. So it's going to be our fourth step in our boot process. I don't know why. Come on now. I don't know why it does that copy paste. Kind of weird. Anyways, so the init-rd or the init-ram-fs, so RAM file system or init-rd, they do the same thing, okay, guys? Let's define these real quick. So kind of back step. We're on our boot process. We do our BIOS UEFI checks, initialization. We're going to load a bootloader, which we call Grub, okay? We're going to get a menu, and Grub's going to say, let's initialize our kernel. So we initialize our kernel. So the kernel is loaded into memory from the bootloader. and the kernel is going to initialize our system hardware. So get all of our compute resources ready to use with our operating system, because we're not there yet. We're not at the actual running operating system yet. But our kernel does not have full access to our file system, so we're going to load up something called initRD or initramfs. So that stands for the initial RAM disk or initial RAM file system. So this is a temporary mini root file system that is loaded into our RAM during boot. So the initRD and the initramfs is going to contain essential drivers, modules, scripts needed to actually mount our full system, okay? So the initRD is a temporary mini root file system that is loaded into our RAM, so loaded into our memory, right? It's going to contain essential drivers, modules, and scripts. And without it, the kernel would not be able to access the file systems on our storage devices, you know? So it won't actually be able to access our FHS. So how does the initRD work? So the initRD, or the initial RAM disk, is going to get loaded up. It's going to load all the required kernel modules for our storage devices, file systems, and encryption. And then once that root file system can be detected and mounted, initRD is going to transfer that control over to the operating system, which is called System D, okay? So this is our 4 basic steps. So bootloader, kernel initialization, hands off to initRD. initRD is going to contain all the essential drivers, modules, and scripts so that the kernel can access all of our file systems. And then we're going to mount the actual operating system. And then once we do that, we're going to mount the operating system. Then we can actually have access to our Linux OS. And this is going to transfer control from initRD to what's called System D. And the System D, what we also call like system control, when we actually do it on like the CLI, now that's going to take over and actually do our runtime, actually run our operating system, okay? And then from there, that's our user space, right? Where we get into the CLI or the GUI. So, a couple things I want to go over. So, what if the initRD system is missing? So, if initRD is missing, we can't load. We essentially can't load our kernel because it's not going to have the necessary drivers to recognize our file system, which is, again, our operating system. Okay? All right. So, that is the boot process written out. So, if you want to take notes, go ahead and take notes. I'll give you guys a few minutes, and then we'll get back into the slides. Or a few seconds, really, not minutes. Okay, I'm going to get out of this whiteboard now, and I'm going to share my screen again. We'll go look at the slides. Get some images in there. So here's what the BIOS will look like. Let's present this. So here's like if you went to the BIOS settings. Remember, this doesn't matter like Windows, Linux. The BIOS menu is going to look the same depending on the vendor. Like HP, Dell, Lenovo, right? So the bootloader. Here's just an image of how it goes, okay? And what we just described. The boot directory. So if we get into our boot directory, it'll show us there if we're using grub or initRD. Just to summarize it, remember, once the kernel fully initializes, because the initRD loads the necessary drivers, and then hands it back off to the kernel. Then the kernel can actually run the operating system. We hand off control to the systemd process. The systemd process we're going to talk about later on. When we want to enable and disable services, once we're loaded into the operating system, it's the systemd process, okay? That's our actual runtime. So grub2, this is going to be the primary bootloader for most Linux distributions. You can see just a picture of what the grub menu may look like. So you can actually change the grub loader too. You can actually do like dual boots on grub. You can change the grub file from the CLI. There's a grub configuration file that we can edit as well, that we don't edit directly, but we can customize the boot menu if we want. So this file right here, the etc default grub file, is the configuration file used in Linux systems that use grub as their boot manager. And then this grub2-make config command, that builds the grub.cfg file, config file, from several sources. And administrators edit the source files, then run the grub2-make config. So you want to make changes, you go edit your grub files, and then if you want to apply those changes on like the next boot, you'd run this command, grub2-make config. Okay. So the systemd, remember, that's when we're in our runtime. That's what controls the system. If you want to view how the system boots, you can use these commands here. Systemctl get default. We can run that command real quick. Systems control get default. So our graphical target, what that's saying here is, hey, we're going to load a GUI system, okay, when we boot. But all right, awesome. So that is the boot process for Linux. Now let's come back to our team viewer here. And we're still installing. So I guess we're going to move on. Alrighty, guys. So let's go ahead and move on to device types in dev. I'm going to bring my notes up over here on my other screen that you guys can't see. And then we'll jump right into it.